Hello everyone, this is Steve. I want to welcome you to my YouTube channel, and this session I'm going to be showing you the video that I've been working on for the collision detection for the spaced out game, of course. You saw me post a video last week about the C64 Sprite background colors, which is right here actually. And this is what I did, is I created a basic program, as I explained in the video here if you want to watch it, that it was basically a path to where I wanted to go to be able to do this in assembly language. Now, this was no easy journey, and if not for the help of people on Lemon 64, I don't think I would have gotten very far with this. But I've been posting a lot on there, and fortunately, eventually I was able to come up with some newer stuff. I finally began to understand how the rotate left and right works and why that was necessary to use that in my code. But anyways, it's working. So believe it or not, I'm so surprised myself it's actually working. I wanted to show that to you. I'm going to demonstrate the game over here. So what it means is I'm moving around here. You'll see at the bottom here the screen. I'm going to enlarge this for a second for those with smaller devices. As I'm moving, it's going to pick up what I'm walking over. So right now you see down here at the bottom of the screen, you see this little yellow, I don't know, it's supposed to be a window or whatever. Graphics aren't important right now. It's all about the implementation, you know, and everything, getting everything working as it should. Anyways, you can see he's lined up with this, and as I move over here again, now he's right by the wall, so it's picking up exactly where he's at by the wall. So as soon as I walk onto the ladder here, bam, there's the ladder. Now as soon as I walk on the ladder, I can now move up and down. Now as soon as I walk a little further, I don't have the second ladder detection in, but I'll put that in later. Now as soon as I walk over here, I can't move up and down anymore. So it basically works. It's detecting when he's walking by a ladder. If he's not walking by a ladder, then it's not going to let him do anything. So it means I can detect any object I want in the game now, right where the sprite is. If I want to detect that window, I could detect that. If I want to detect a walkway, I could detect that. Anything. I mean, it's all now possible. So let's see where this ladder is, right there. Okay, so if I go back here, you notice you can't move up. Now as soon as I go over, I can't move up. But as soon as it pops in, now I can move up and down. So it's my dream. I need to create some up and down movement, and I do have the sprites in here. I just haven't added them into the game. But it's working, guys. This is awesome. So I'll be able to eventually add in gravity when he falls off of stuff, you know, and get the thing finally moving ahead. Like, I want to make it so once he walks over here, he'll go down the stairs or something like that, you know, or something like that. So if there's objects on the screen, I can now detect them. And for those who don't know, this is a sprite trying to detect a background. A sprite is 24 by 21 pixels, and a background character is only 8 tiles. So there's a huge difference in trying to reference those to be able to, you know, for them to be able to overlap and see exactly where they collide at. So I'm moving over here. So it's probably picking up this thing right by his head here. It might be a little bit off. Actually, it looks like it is a little bit off. So there's probably still some more work I need to do with it. Let's see how close the ladder thing is. Yeah, it seems to be a little bit off here still somewhere. But it won't do anything until that ladder shows up. That's the only time he can move up and down. So once I get that positioning going, it should be working really well. Bugs me it's still off a little bit. Okay, let me see here. So see, this is actually picking up above him. This is probably why it wasn't working. So it's still not picking up the Y position or something. I probably need to be able to change that later. And I just need to go and implement the routine. So it's picking up that ladder instead of the one above him. So but I'm getting pretty close to getting it done. So this is the closest I've ever been to anything, you know. I'm gonna wait till I get up to a ladder again so I can move up here a little bit. Just wanted to demonstrate here, but actually I'm gonna move back here again. Just move down a little bit. If I get in the right position, it should pick up the walkway here somewhere. I don't know where that purple's coming from. So it's off by a little bit on the position. This stuff is no way easy to do. A limit 64 makes it very easy, but those people have been doing it for a while, so I'm no expert on the matter. At least that ladder actually lined up. Look at that. It's going to be a lot of work trying to get this perfected, but I wanted to show you guys it. So I have some kind of video to show you each week. Notice what it's doing is it's still picking up right here, kind of where he was earlier. Alright, let me go back here. So see it? I can move backward and forward, and then once I move forward with it again, it picks up the map. Even though it's not correct there. You can see down at the bottom here, it's detecting the ladder. So once I get that lined up, it should be good. So anyways, if you want to see the code, I guess we can go to that next. It's actually right here. So like I said, a lot of this is not my own work. A lot of this was accredited to people who helped me on Lemon 64. So website here, right here. It's this one right here. So this is Lemon 64, and these people have really contributed to helping me a lot, even though some of them are kind of picking on my code and stuff. But yeah, I know it's messy. I know it needs work. It's not a completed project, so they can say whatever they want about it. Seriously, it's just in beta, so as I'm going through beta, it's going to be sloppy until it's finally done. But anyways, at least it's working to an extent now. So anyways, the first thing I did is I initialized the screen for the 0 page, the low and the high byte, which, you know, 0 plus 4 times 256 is 1024, to pick up where the screen's going to pick up the data at that he runs into. And then the next thing I did here, let me pull up my other one. I have it open here too somewhere. This is the basic one that you saw on the YouTube channel example. So this is the program that I ran and demonstrated earlier that has allowed me to create it in BASIC and get it working, and eventually get it working in assembly language. So I wanted to show this to you because here is where I kind of got the formula xc equals x minus 40 divided by 8. That's what this is doing. It's picking up the x1, which is where the player's x position or his horizontal position falls at. And then it's subtracting 24 from that, since the sprite is 24 pixels in length, or width, excuse me. So it's from, you know, this way going left to right. And then the next thing is LSR, LSR, LSR. For those who don't know, this is just multiplied by 2, 4, and 8. So, say multiply, divide. So it's, if you look here in the routine, you'll see it's dividing by 8. So it's basically taking this, and it's just following this order. X minus, well, this one should be 24, but somebody corrected me on that. But anyways, when I had it corrected originally, it should look like that. So 24, and then it divides by 8, and then it just stores it in an X character, just a location where you want to store it at. The same thing with the Y. You'll see down here, YC equals Y minus 21 divided by 8, and it's the same thing I did up here. Very kind of repeating what we did earlier. Create the Y1, and then subtract from that 21 pixels, because the sprite in length, is that length? Well, like, you know, up and down. It's the width, the length, or something like that. But anyways, up and down is 21 pixels high. And then LSR, LSR again is 2, 4, and 8 to do the division of divided by 8. So left shift right, when you left shift right the accumulator, it moves it, you know, the value over this way. Probably bad at explaining that, but it moves over. The bits are moving over to the, I'm saying it right, to the left. Excuse me. That's why it's called a left shift right. Confusing name, but that's what it's doing, is it's moving over. until it gets to the 7th bit, and then after the 7th bit it does what's called a carry flag, which allows the carry to happen. Anyways, I had that back, but actually ASL goes left, I think, and the other one goes right, but I don't know. But anyways, the whole idea is that in the memory, it's how your computer is adding and multiplying. I'm really bad at explaining things sometimes, guys, so you have to kind of excuse me on that. I'm always better to write things down, which I did have this all written down somewhere. Of course, right now I'm not going to be able to find it. I think I wrote it down here. Yeah, here's my copy right here. So glad I wrote this down. But anyways, this so left shift right goes to the apparently accumulator shift left, which is the multiplication, goes to the left, and this one actually goes to the right. See, left shift right. Okay, that's what it is. Left shift right. That always confused me. Left shift right or right shift left because of the L. But anyways, that's what it stands for. Left shift right. So you take the last value, and that's where it's shifting to. So as it shifts over there, it gets to the 7th bit and it completes that carry. But I don't have a video where I think I could probably pull up something and show it to you, maybe. I probably won't be able to get my camera working. It wasn't working for a while there. Maybe it will work. Who knows? I get lucky. Oh, it actually is working now. For some reason earlier it wasn't working, but anyways, I'll show it to you real quick here. We'll go back to the old Atari days when I kind of explained things. I hope you can see this. I'm going to have to kind of... You see what says ASL and this says LSR there? It shows which way the bits are moving, and they're numbered from 0 to 7. Well, actually, I need to do something real quick. I should have paused that, but oh well, sorry. Had stuff in the oven. Anyways, yeah, that's what's going on with the accumulator. And then these are the bits that are shifting in the accumulator. Right there, so you can see the left shift is moving from 7, 6, 5, 4, 3, 2, 1, 0 until it gets here to the carry flag. And you'll see I wrote down there, it can be used to unpack data. So there's other things you can do with it. But anyways, the accumulator shift left is the multiplication, and it moves it that way. So just thought you might need a quick assembly lesson on that. But that might come in handy when we start talking about this more in-depth stuff. This stuff's gonna kind of blow your mind, but I think the easiest way to do this is to copy this over here before I go into this to explain this, so people know what these variables are for. Which is right here. I'll just copy this whole section. I'm going to throw it in a notepad here. So that you can kind of see as I'm going through it what all this means. Okay, so we're back here. So this time we're loading the Y, and keep in mind this is just keeping track of X, and then this is keeping track of Y. That's why I stored it in Y character. So that just like down here in the basic example, when I'm done, I can use these routines for different things. Where did my thing go? Let me just put this over here somewhere. So now you can see over here the thing, and somebody showed me this code, is what you want to do is you want to zero out the 40th. Well, we're using a variable, or whatever you would call this, to clear in memory. This is going to be used for the math, which you see down here. What we're trying to do now is we're trying to calculate this line right here. This is BL equals 1024 plus XC plus 17 plus 40 times integer. You can ignore all this minus stuff, but anyways, it's going to say times YC. Let me just fix this. I had fixed this, but I had never saved the original value, so I don't need this right here, and I don't need this minus 13. So or something like that. Okay, that's good. And this is erasing this value that we're going to store so that we can just start working the math. And this first one right here is going to be used to detect this 40 times. Because when you're multiplying in the accumulator, if I can show you this real quick here, every time you do an ASL, that means accumulator shift left. You saw me earlier put that up on the screen, and what it's doing is it's moving the values to the left. You always go by the last letter, and that's how you'll know. So as we're moving the bits to the left, we're going to eventually hit the carry flag. But every time we're shifting it left, we're multiplying it by the bits that are stored there. So times 2 times 4, and it's being changed, or not times 5, excuse me, times 8, times 16, times 32. But there is no 40. There's no times 40. There's a 64. So you have to accommodate after you get to the 32. What to do here is, if somebody explained it, you need to break it up into 2, 4, and I think it was 8 or something like that. And then once you have that, you take the 8 times the 30, or 32, not times the 8, 32 plus the 8, which we know is going to be 40. So that's what's going on right here. Now this stuff might kind of confuse you. Trust me, this confused me for the longest time. This rotate is necessary to get the high bit, because anytime we multiply, and I'll pull up my calculator to demonstrate this. It's going to be kind of a long video, so bear with me on that, guys. So anytime we multiply it by 2, keep in mind that this y character value, if you see down here, I'll kind of print it and show you what it is down here. It's going to show the decimal version, but anyways. Oh, I need to run it first. Let me stop this and list this. We can see it, and then I'll just print the values out here so we can kind of see them. So this x, or this yc is 11.75. So in here, it just rounds it up to 11. Well, it's actually doing the decimal equivalent, but the number is only going to show you 11. So for example, if you go and you run the game and you put a break in it, you can look at the monitor over here, which I could probably do it right here too. I probably don't even need to break it. But here's yeah, it kind of sets it in motion here. So if you go here, we're now looking in the accumulator's memory here, or the computer's memory, and use M, you can kind of view things in memory. So it's going to let you see what's going on with these values and stuff like that. And you can also check the status register. I think it's this one right here. This will show you what the X register, Y register, stack, and all that is actually doing. And this is the program counter, just showing probably where it stopped at or whatever. The flags, the negative flag, and all that stuff. But not to be a complete assembly lesson, I just wanted to show that to you. And anyways, that's what we're doing here. I don't want to really go over all this because this probably could take a while, but it's multiplying this by 2 when it hits the SL, as I demonstrated here. And then it's rotating the high bit so we don't lose the high bit, because if we go over, I know I was going to explain, if we go over the 32, it'll be a higher number. So it can't go, remember, it can't go past 255. So if we just take 11 times 2, that's 22, or 40. What is wrong with this thing? 11 times 2 is 22, and we take 11 times 4, it's 44. I have no idea how to clear this. 11 times 8 is 88. So now we're still under 255. So 11 times 16 is 176, which I believe, let's see, 1, 2, 3. Oh, I actually have it right down here. So this equals 176. So this last ASL here is equal to 176. You can see I kind of broke it down here too. Let me scoot this over a little bit. I don't have enough screen here to show you everything, but anyways, 11 times 16 equals 176. And of course, after anything beyond the 16 is going to go over 255. So 11 times 32 will be over 255. So it's actually, I demonstrated that here, but it, or somewhere in code here, I don't know if I wrote it down here or down here, maybe somewhere. The 255 is already over, but now you have to carry the bit as I explained earlier. So I just say 255 minus 252. What is wrong with this thing? 255, oh, I did that backwards. So 352 minus 255 would show me the bits that it's over, so it's over 97. So with that, you can kind of figure out what the high bits are, or just like doing basic math, we had to do the carry whenever you do multiplication. You just had to do the carry and, you know, and everything pretty much. And that's how the accumulator works. It's just carrying values over. And then we're saving them down here. As they demonstrated to me, you have to save them so that we can reuse this later. So we got the low right here, and we got the high byte. And remember, that's just necessary because it's going to be over the 40, and we need to know what the high byte's going to be, and then anything under that, we're going to need to know the low byte. I know that probably blows your mind if you're not into assembly, but trust me, it works. You saw it here earlier. So this was my old code, so I just kind of commented this out in case I decide to use any portions of it. So once we got these two values down here, as you saw here, the VL, I could demonstrate this down here. So if you take the YC, or 40 times, where's it, times integer YC, it's 440. So that's the value that we're shooting for when we're multiplying. So right here I showed you 440 minus 352. And I'll just go back on here. 440 minus 352 is 88. And then plus the 176. And then there's 2 for the 176. And I kind of showed how it added up to 140. So it's taking the high and the low bytes. Well, this is the, it's taking the 88, which I think I showed that to you earlier. So we can kind of break this down. So to show you over here, so it's 11 times 2 equals 22, 11 times 4 equals 44, 11 times 8 equals 88. So this is necessary, as I demonstrated earlier, so we can take this multiplication by 8 and this multiplication by 32, add them together to get to 40, so we can integer and multiply by 40. Otherwise there's no way, because there's no value to multiply directly in 40 in assembly, of course. I might be able to explain why. Let's see if I wrote this down. Yeah, I did. I'll show that. Pull over to the camera real quick here. So back to this again. You see that value right there? Yeah, but gosh, I hate when I can't see this. Okay, so right here, the 128, these are the values that I'm referring to. And then we'll multiply by 2, by 4, by 8, by 16, by 32, and so on. So anything past the 32 obviously creates a number higher than 255. So that's why you had to break them up that way to get the values to correctly, you know, multiply together. Well, that's a handful. But anyways, once you're done with these, what you want to do now is you see down here in this line, which is, let me just list it, it's actually line 190. 190. So I'll just screw this up a little bit. So you can see right there, and I forgot to change this too. Take out the 17, that's 2, 13 there. I forgot to hit enter probably. So that's the line that this is all doing. So the first thing it's doing is it's keeping track of, ignore the 1024, that comes in later. But first thing we're doing is we're getting the XC, which is our X character right here. And the next thing we're going to do is we're going to multiply our 40 times our integer. Remember when I showed you the calculation up here earlier, what I forgot to mention is once you're done with all this, you're saving this. So this is the high byte. And somewhere in here is the low byte saved. Let's see, I think it's right here. That's the high, right there is the low, right there. So it's the low byte, and then that's the high byte being saved. So once you have those, you're calculating them down here. You're adding them into ZP temp low, which is just 253, the 0 page, so we can start peeking at the screen. 253, remember, is just keeping track of what the characters, where screen memory is falling at. Because I showed you earlier where we initialized to 0, 253, and 4 in 254. So we know from the old calculation that that equals 1024, which is where screen memory starts. So this is how it's reading in the screen memory pretty much. And of course we got the high and the low byte, as I demonstrated, of the 40. Well, we're getting the high of the 40 here. Yeah, because this one didn't go over 255, so this is probably the one that just does the, yeah, this is the one that stays under 255, so we're getting a high of this. And then we're getting the low and the high of those two numbers we needed. Remember, these were the numbers that went over 255, which was the 11 times 32. Remember, that was 352, which is higher. So we're breaking up this 352 into high and low bytes here. Low and high bytes right there, so that we can effectively read this in the computer and make it figure out where it's falling at on the screen. And that's going to work. It's supposed to work when I move up and down, but I haven't, put that into the game yet. But it's all in here. It's all in code. And then down here, we're adding in the X character. Trying to figure out why I did load the accumulator there. Oh, I think this is something I was doing when I was trying to move the Y position. I couldn't get it to work. But anyways, once you have this all done, you just store it in the screen down here. And I just called mine temp Y. Not even sure if I even needed that. Let me see. Yeah, because it stores in the 0 temp low. So this is what the main thing is doing. So probably everything after this I really don't really need. All this I could probably just X out. Because all we need is just to store in the temp low and the temp high. This screen temp Y was an old variable I was using, but I'm not using that anymore. Okay, then this can get erased too. This was old code I had. So now what we're going to do is once we have all these calculations, we're doing this, as I showed you, the YC, where was it at here somewhere? YC plus 40 times n, or did I do that yet? Oh, right here up above. So 40 times integer YC is equal to 440. So this is all going to be stored in here, so we can figure out where the sprite position falls at when he touches a character on the background. And this was a little bit tricky. I couldn't get the positioning work right. I couldn't make it detect stuff on the screen right. It was not working, even though I could see down here in the line where it shows the picture to demonstrate what he's crossing over. I could not get that to right. So finally I figured out the only way to do it was to store it into a variable. And that's what I did here, or a label. And I know I was using the wrong word, but a label, stored into a label there. And then this stores it to the screen. Of course, this 1890 is just storing it down here. That was the only way I could get it to work. And then later, I'll show you, I used that up in the up and down routine. But anyways, if it's, so it's, he's saying if it's not, well, I guess we could skip this part. So we might have to come back here. So it's saying if there's no ladder detecting here, then what we're currently going to do is shut the up and down position off so he can't move up and down. So this basically will fire every time consistently. So it's going to keep the values off because they're going to be turned on in the up routine, but I'll show that to you here in a minute. And this is just a loop to go back through the Y, so as he's moving over here we can detect all the characters he's crossing over. As the game's still frozen here, let me just shut the monitor off. So as I'm moving over here, it's detecting where the next character is going to start drawing on the screen there. So that's why the increment Y is necessary. So now to go up in the upper routine, I called it right or left or something. There's too many lefts in here. Can't remember what I called it, but I'm going to the left and the right routine. It's in the joystick routine here. So here's the left movement. So we'll just start with the down movement, which is below all this. Oh, actually it was right above me. I forgot that. Okay, so actually it's above this. Let's see. So right here. So here's the move down routine, and this is detecting when he's moving on the ladder. So remember that is ladder. His ladder is just detecting when he crosses over something, and it's peeking into 253, Y to figure out where that screen memory value is falling at. So what I did is I obviously have another, I can show you this, my old character pad here. These are the values here that are from the character set. So if you look over here, you'll see 13 is the half part of the ladder, which is this side, or the left side of the ladder, and 14 is the other side, right there. So that's what I'm doing, is I'm detecting the ladder here. I'm only detecting on one side here. And then if their ladder is existing, then we're going to change the color. So let me move over here so I can get to ladder and hopefully get this to work again. Right there, so I go back. And it won't let me go back here because I trapped in my screen. Let's get to the next ladder here, maybe. There's one right there. Okay. Oh, daggone it. I have the screen blocked so he can't go past the screen here, because this is where I wanted him to stay. It was in the main screen, but later I'm going to fix all that. Let me see if I can pick up the next ladder here. Hopefully. I think it's still reading this top line up here. It's not reading the bottom one, as I mentioned before. So let's see where the next ladder is at. It'll be right there. Oh, right there. Okay, so now he can move up and down. And then once he's able to detect where the ladder is, you notice the screen changed, the border changed color. It's all I did here is just to kind of detect that it's working. I can cut that out later. I don't really need to change the color. I just wanted to do that to test for myself. And then, of course, I showed you this unlock down earlier. Remember, it was set to 0. Now it's set to 1, which is going to allow him to move up and down pretty much. This is detected down in here. I was trying to remember where I detected it at. Actually, it might have been somewhere else. Let's see, because I had a different routine before. See, unlock down. Let's see. Yeah, it was probably down in here somewhere. Let's see, is ladder 13? Oh, no, this is it. Because if it's not 13, it's skipping the routine right here. Originally, I just tried to make it check just like, say, it load the cumulative up lock down or up lock up and see if the value is 0 or 1. But I figured it was better now just to skip it. If the value's not 13, then we exit that routine, which means there's no ladder in detection. Otherwise, if it's in detection, it turns on the up and down for both of them down here. Here's one for the up, and then there's one for the down, as you just saw demonstrated here. I can see I can't move up and down now. If I try to move up and down, but as soon as I go over, now I can move up and down the screen. Of course, got to get that lined up for later, but you can see it's getting close to what I want it to be. So that's pretty much all I wanted to show you guys. I didn't really have anything else to show you in this video. This has been a long, grueling week trying to get this thing moving, and I've been working on it longer than that actually, but still got a long way to go. I mean, designing a game is no easy aspect, but as somebody mentioned, it'll have its rewards later. So yeah, I just wanted to show you guys that. Send me your thoughts, ideas, or whatever. If you have any suggestions even to fix it, better it, that would be good too. Let me do one other thing here. I mentioned this earlier. I wanted to see if I could get this Y lined up by changing the Y variable instead. In this, right here, this, I don't know why I put that in there. This X character, I could also change this just to a Y character. Shut this down, and rerun it. Let's see if it lines up the Y this time. So it's still lining up the X. The X is good. Now if I go down here, let's see, does it change to the bottom? See if it detects this ladder or anything. Yeah, it's still reading up here for some reason. Oh well. I know I have